The question, if f of x is a function such that f of x plus y is equals to f of x plus f of y and f of 1 is equals to 7, then sigma r is equals to 1 to n f of r is equals to. Here there are few functional equations based on the given conditions. They are f of x plus y is equals to f of x into f of y, f of x into f of y. Such function is exponential function. F of x plus y is equals to f of x plus f of y. Such function is a linear function. F of xy is equals to f of x plus f of y. Such function is a logarithmic function. In that way, here given that f of x is equals to kx, f of 1 is equals to 7, this implies k into 1 is equals to 7, k is equals to 7. Therefore, f of x is equals to 7x. Summation r is equals to 1 to n, f of r will be f of 1 plus, f of 2 plus, f of 3 plus, so on plus f of n. F of 1 is 7, f of 2 is 14, f of 3 21, so on. F of n is 7n. 7 taken out common, 1 plus 2 plus 3 plus so on till n. This is equals to 7 into n plus 1 by 2. 7 n into n plus 1 by 2 is answer. Okay, very simple question. When you know this functional equation, so this is the function satisfying the given condition. Okay, see, let's move on to question number 2. F is mapping from R to R, be a function defined by f of x is equals to x square minus 4x plus 3 when x less than 2, x minus 3 when x greater than or equals to 2, then the number of real numbers x for which f of x is equals to 8. The number of real numbers x for which f of x is equals to 8 is, okay, do observe that x greater than or equals to 2, f of x is equals to 8 implies x minus 3 is equals to 8, x is equals to 11, which is possible value. Because of x is equals to 11, x greater than or equals to 2 condition satisfied. X less than 2, f of x is equals to 8 implies x square minus 4x plus 3 is equals to 8. X square minus 4x minus 5 is equals to 0. X minus 5 into x plus 1 is equals to 0. X is equals to 5. X is equals to minus 1. Just x is equals to minus 1 only will satisfies x less than 2 condition. We are also getting x is equals to 5. When we are writing x is 5, 5 square 25, minus 4 into 5 20, 25 minus 20 is 5, plus 3 8 we are getting, but we are under x less than 2 case. So number of such possible values only 2. This is one of the value, this is another value. So number of possible values only 2. Okay, very important question. It is a previous year Eamcet question. Okay, next, the set of all real values of x for which f of x is equals to log of 2 power x minus 2 to the base 2 plus root 1 minus x is also real. Do observe that function is real means function is defined. Function is defined means set of such values of x is called its domain. So here there are two functions. One is a logarithmic function, other one is a square root function. Logarithmic function defined only when it is real number, only when 2 power x minus 2 greater than 0. This implies 2 power x greater than 2 power 1. This implies x greater than 1. Okay. Next, square root 1 minus x is real only when 1 minus x greater than or equals to 0. This implies x less than or equals to 1. Okay. So, simultaneously, can you expect the value which is greater than or equal to 1 and which is less than 1? Is there any real number which is greater than 1 and same real number is less than or equals to 1? Is it possible? No. This is real line. This is real line. Somewhere here 1. Greater than 1 means these numbers will come. Less than 1 means these numbers will come. There is no common value for x. So, even though x is equals to 1 here, but x is strictly greater than 1. So, real number x which is greater than 1 as well as less than or equals to 1 is impossible. Greater than 1 there are infinitely many real numbers. Less than or equals to 1 there are infinitely many real numbers. But same x cannot be greater than 1, cannot be less than or equals to 1. There is no such real number. That's why answer is empty set. There is no such real number. Okay. So that's why answer is empty set. Problem number 4. The domain of the real valued function f of x is equals to square root of 2x square minus 7x plus 5 by 3x square minus 5x minus 2. Do observe very carefully and very easy question also. Square root function is defined, means square root function is real. Square root function is real only when root x is defined for x greater than or equals to 0. X greater than or equals to 0. That's why f of x is defined for 2x square minus 7x plus 5 by 3x square minus 5x minus 2 greater than or equals to 0, which implies factorization 2x square minus 2x minus 7x plus 5 by 3x square minus 6x plus x minus 2. Factorization 2x taken out common, 2x taken out common, x minus 1 minus, this is 5x, sorry, minus 5 taken out common, x minus 1, that's why 2x minus 5. Denominator 3x minus, so x minus 2, 3x taken out common, x minus 2, plus 1 taken out common, x minus 2. This is the factorization. From here onwards, we have to use wavy curve method. 1, 2, 5 by 2 is 2.5 minus 1 by 3. Okay. So, plus region or 0 region we need to calculate. It is equals to 0 at the time of x is equals to 1, at the time of x is equals to 5 by 2. At 1 and 5 by 2, we have to use closed interval. For all the remaining cases open. This is positive region. However, at minus infinity open always. at minus 1 by 3 also open, union, closed 1 comma 2 open, then after union, closed 5 by 2 comma infinity open, closed 5 by 2 comma infinity open. First option is right answer. So wavy curve method is important here. Okay. Next, problem number 5. The range of the real valued function f of x is equals to modulus x minus 2 plus modulus x minus 3. Okay. Range of the real valued function. It occurs minimum or maximum value at x is equals to 2 or x is equals to 3. Solution. F of x is equals to modulus x minus a plus modulus x minus b has minimum value at x is equals to a or x is equals to b. So that's why minimum value of f of x, minimum value of f of x is f of 2. F of 2 is modulus 2 minus 2 plus modulus 2 minus 3, that is 1. Minimum value is 1. Maximum value at x is equals to infinity only is infinity. Why? Because modulus function always greater than or equals to 0. So it has no maximum limit. That's why its range is closed interval 1 comma infinity open. Okay. So this is the way. Next, the domain of the real valued function f of x is equals to square root of 6x square plus 5x minus 6 by square root of 4 minus x minus square root of x plus 4. Okay. Domain of the real valued function. We know very well that square root function, just it is enough to remember, square root function defined for x greater than or equals to 0. Okay. Solution. Numerator is defined for 6x square plus 5x minus 6 greater than or equals to 0. 36 means 6x square plus 9x minus 4x minus 6 greater than or equals to 0. This implies 3x taken out common, 2x plus 3 minus 2 taken out common, 2x plus 3 greater than or equals to 0. This implies 2x plus 3 into 3x minus 2 greater than or equals to 0. For this wavy curve method, minus 3 by 2 somewhere here, plus 2 by 3 somewhere here, plus minus plus greater than or equals to 0 happens when minus infinity comma minus 3 by 2 closed, union closed 2 by 3 comma infinity open. This is one of the case. Okay. Next case, square root of 4 minus x defined for 4 minus x greater than or equals to 0. This implies x less than or equals to 4. Next, square root of x plus 4 implies x plus 4 greater than or equals to 0, which is x greater than or equals to minus 4. See, on the same real line, we can also see minus infinity to plus infinity, somewhere here minus 3 by 2, this is plus 2 by 3, and this is 4, this is minus 4. It is giving this domain from the above case, and x less than or equals to 4 means this is the region. X greater than or equals to 4 means this is the region. Now the common case is minus 4 to minus 3 by 2 union 2 by 3 to 4. So this is the common case. This is the common region. So this is right answer. Its domain is closed interval minus 4 comma minus 3 by 2. Okay. Union 2 by 3 comma 4. 2 by 3 comma 4. Okay. So this is the domain of this function. Let's move on to next question. Number 7. If step x represents the greatest integer less than or equal to x, then the range of the real valued function f of x is equals to 1 by under root step x whole square plus step x minus 2. Do you observe that? So first of all, f of x is equals to 1 by root of step x whole square plus step x minus 2. This can also be converted as perfect square like this. Step x plus 1 by 2 whole square always positive. As x values are increasing more and more, suppose x is tending to infinity, its value is infinity. Wherever x is large, function has minimum value. So that's why this is infinity. Minus 9 by 4 also tending to infinity. That's why that is the maximum value. Infinity is the maximum value of denominator. Function minimum value is 0. Okay. Almost minimum value tending to 0, not exactly 0. And at the same time, its domain is required in order to find range. Step x plus 1 by 2 whole square minus 9 by 4 strictly positive when step x is equals to 2. After that, at many places it is positive. So in that way minimum value is 2. In that way minimum value is 2. Minimum value 2 means maximum can be 1 by under root 2 plus 1 by 2 whole square minus 9 by 4. 2 into 2 4 plus 1 5 by 2 whole square 25 by 4 minus 9 by 4 16 by 4, that is 1 by root 4. 1 by root 4 is 1 by 2. Now the range is, therefore range is minimum value open interval 0, maximum value closed interval 1 by 2. So this is the range of the function. In order to find range, this step is very, very important. Okay, is positive when step x is equals to 2. Next question. F of x is equals to log of x plus root of x square plus 1 is an even function, an odd function, a periodic function, neither even nor odd function. Do observe that f of x is equals to f of minus x. It is an even function. F of minus x is equals to minus f of x. This is an odd function. Okay. So in that way, let us try to simplify f of minus x. That will be log of minus x plus under root x square plus 1, which is log of minus x plus root of x square plus 1 by denominator minus x minus root x square plus 1, rationalizing the numerator x square plus 1. In the numerator we get a plus b into a minus b, x square minus of x square plus 1 by minus x minus under root x square plus 1 gets cancelled. Minus 1 by this, minus gets cancelled. We get 1 by x plus under root x square plus 1, which is log of x plus under root x square plus 1 inverse, which is minus log of x plus root x square plus 1, which is same as minus f of x. F of minus x is equals to, finally we got minus f of x. That's why it is an odd function. Okay. Next, the domain and range of f of x is equals to cos x minus 3. This is f of x function, or respectively. Very clear, f of x is equals to cos x minus 3. 3 is a constant function. That's why domain of cos x will be the domain of f of x. So however, domain of cos x is capital R. In order to find range, we know very well that minus 1 less than or equals to x less than or equals to 1, and minus 1 minus 3 less than or equals to cos x minus 3 less than or equals to 1 minus 3, subtracting 3, minus 4 less than or equals to cos x minus 3 less than or equals to minus 2, minus 4 less than or equals to f of x less than or equals to minus 2. Therefore, range is equals to closed interval minus 4 comma minus 2. Do observe that domain of your function is capital R, range of your function is closed interval minus 4 comma minus 2. So this is the way to find the range of your function. We have to bring f of x by using suitable operations. Okay, this is the way to find range of the function. Next, question number 10. The domain of the function f of x is equals to 1 by square root mod x minus x. So such function is defined only when mod x minus x greater than 0. Square root function that is in the denominator, actual square root function is defined for inner quantity greater than or equals to 0, but it is in the denominator, that's why it should be strictly greater than 0. This is mod x greater than x. Mod x greater than x possible only when x less than 0. Suppose x less than 0, x value minus 5, modulus minus 5 greater than minus 5. So that's why x less than 0. X less than 0 means its domain 0 to left hand side, that is open interval minus infinity comma 0. X less than 0, open interval minus infinity comma 0. Okay, this is answer. Okay, so these are the models from functions. Dear students, those who are watching first time my YouTube channel, please do subscribe so that you will get notifications.